Hey, Mr. Stouffer, this is our stats project. It's Sam.
Ellie,
Anna, and Cha. The question that we're hoping our experiment will answer is, are boys more likely than girls to be told that they have food on their face? Just to note, this only applies to the Eastridge population because of our sample.
using the different lunches A, B, C, and D as strata, we took a stratified random sample of the lunch tables. The 69 lunch tables, or places where people sit, were assigned a number 01 through 69. For each different lunch, so for A, B, C, and D, 20 tables were randomly selected for a total of 80 tables. These 20 tables per lunch were then assigned a number 01 through 20. An SRS was taken of these tables to randomly assign the table to the boy or girl group. We will go into more detail with this so that it is less confusing.
Here is a map of the cafeteria. The tables are numbered 01 through 69. You can see we included the areas that students sit that you may not consider a table because we wanted to make sure that we included as many students as possible, such as the stairs and the chairs by the window.
So using the random digit table in the back of the book, we selected 20 tables based on their assigned two-digit numbers from each lunch to be a part of the experiment. Obviously, we skipped numbers 70 through 99, 00, and repeats, and you can take, for example, the 20 tables that were randomly selected for a lunch.
The next thing we did was assign each of the tables selected for each lunch a number 01 through 20. We then used the random digits table again to randomly assign each table to a treatment group, boy and girl. The first 10 tables selected were put in the boy group, and the rest were put in the girl group. We skipped numbers 21 through 99, 00, and repeats. As you can see here, we have, from the example of a lunch, those tables that were selected to be the boy group, and those that were selected to be the girl group. The tables listed above are still labeled as the number originally assigned to them, but they were reassigned the numbers 01 through 20 for the purpose of being placed in a treatment group.
This process was then repeated for the remaining lunches B, C, and D. This is a map of the tables that were randomly selected to be approached in a lunch. Green highlighter shows that they were approached by the boy, pink highlighter shows that they were approached by the girl. The same for B lunch, same for C lunch, and finally D lunch.
The boy we used was Chumba, and the girl was Ellie. They both approached the tables that they were assigned to. They both had a script that had a conversation that were very similar. Both actors put a glob of ketchup about the same size on the corner of their mouths. Here are them with the globs of ketchup.
Here's a script of the questions Chumba and Ellie both used. Just note that a lot of the tables had specific questions that they both answered accordingly.
For our experiment, we defined a success as having an actor told directly that they had ketchup on their face, and a failure of them not being told that they had ketchup on their face. In order to have a success, anyone at the table had to point out, whether by literally pointing at it or by telling the actor, not the other people at the table, that the actor had food on their face.
Here are some graphs that represent our data. So as you can see, this graph shows the breakdown of each lunch of how many successes the girl had versus how many successes the boy had. This is the total number of successes for each gender. As you can see, there were 10 people who told the girl that she had ketchup on her face, and there were 17 people who told the boy that he had ketchup on his face. This is a proportion breakdown for each. So this is for the girl. The girl had a success rate of 25%. This is the proportion graph for the boy. The boy had a success rate of 42.5%.
We want to perform a two-sample z-test for the difference in proportions to answer the question of whether boys are more likely than girls to be told by their peers that they have food on their face. The significance level we are using is 0.05. The null would be P1 minus P2 equals 0. The alternative is P1 minus P2 is greater than 0. P1 is the proportion of tables that told the male actor that they had ketchup on their face. P2 is the proportion of tables that told the female actor that she has ketchup on her face.
So for our conditions, the random condition was verified because we had randomly selected tables that were randomly assigned to treatment groups of boy or girl. The normal condition was verified because for the boy, we had 17 successes and 23 failures, both being greater than or equal to 10. And for the female, we had 10 successes and 30 failures, both greater than or equal to 10. The independent condition was verified because the tables were randomly assigned to treatment groups, assuming that one table does not affect another.
Our N1 and N2 are both equal to 40, as you can see. This means that our P1 is calculated to be 17 out of 40, which is 0.425, and our P2 is calculated to be 10 out of 40, which is 0.25. Recall that P1 is the proportion of males, and P2 is the proportion of females.
Because this is a significant test for the difference of proportions, we have to calculate the pooled statistic. To calculate this, we took the number of tables that told the female that she had food on her face, plus the number of tables that told the male that he had food on his face, all over the sum of the two sample sizes. This ended up being 17 plus 10 all over 40 plus 40, which simplified to 27 over 80, which simplified to 0.3375. This was our final pooled statistic. To calculate the z-score, we took the statistic minus the parameter all over the square root of p sub c times 1 minus p sub c all over n1 plus p sub c times n1 minus p sub c all over n2. As you can see, I'm not going to read through that whole calculation because you can read, and we ended up getting a z-score of 1.66. Using the z-score table, we found that the z-score corresponded with the value 0.9515. So our p-value, in order to calculate the p-value, we had to do 1 minus
0.9515 to get the value of 0.0485.
The p-value we got was 0.0485, so p-value is less than 0.05. We reject the null, and there is enough evidence to conclude that boys are more likely than girls to be told that they have food on their face.
Some of the pitfalls of our experiment include the fact that not all of the conversations went exactly the same because there was small variations. Not every person at the table was necessarily paying close attention to Chumba or Ellie. Chumba is clearly a different person than Ellie. Different people know each of them, and as you know, Chumba is a character. Students who eat in the library, pods, or have PSCO have open hours were also not included in the sample.
A few additional pitfalls include that not all of the tables had the same amount of people at them. For example, some of them might have had one person, or some of them might have had full 12 people. Another one is that the size of the ketchup was not exactly the same for every single trial, because it had to be reapplied every time it was pointed out, because they would wipe it off. Another one is that the data only applies for ketchup, not for all food being on your face.
If you have any questions, just ask us in class.